Hi everyone, in this video tutorial we will modeling drilling operation using Abaqus. Let's get started. First, let's start with creating of our parts or creating the working piece or stock. Let's go to create part, stock. We will use 3D deformable solid extrusion and use one as approximated size of our viewport or work view. Let's create our sketch rectangular with dimensions equal to 0.1 and 0.1 meter. All units in our modeling, this modeling is in meter as dimensions, unit of dimensions, and also in the Pascal as unit of materials and stresses. Click done, and let's add thicknesses of our stock 0.01. That means we have 1 centimeter or 10 millimeter in the width of our part. Click OK. Now we have our workpiece. Let's go in the second part. We need to import the drilling tool from another CAD software. Let's go to File, Import, Part, select this tool, click OK. Now let's name it drilling tool, and the dimensions of our tool is in the millimeter. We need to convert to. Let's go first to combine into single part, merge solid regions, and in the scale, let's multiply or divide by 1000 to convert millimeter to meter units. Because we have our tool is in the millimeter, the radius or diameter of our tool is equal to 25 millimeter. By add this option, use multiply. No, we use 0.001, not 1000. That means we convert the millimeter to a meter unit. Click OK. This operation is running, importing operation. The part drilling contains precise geometry, which slide it, dismiss. OK. Now we have drilling tool imported, and also we have the stock. First, let's go to assembly to see the assembly between two parts. Apply. Let's translate our parts in the right positions, each others. Let's translate this part to the 0 point. Let's create middle points. And select this part, select this point and translate to 0 point. Click OK. Now we have assembly of our stock and drilling tool. Let's translate the drilling tool upper, then this position, select the 0 position and translate to Z direction equal to with 0.02 millimeter in the reverse direction, minus. Now click OK. The drilling tool is translated in the upper and the surface of contacts. I think we have a problem. Okay. From in this select minus. Okay. Now I think we have the right position. And now we have done with the assembly module, and let's go to property module and import. And before that, let's first go to part module and convert this part to rigid part. Let's edit and convert to discrete rigid. Click OK. Now we have this part analyzed as rigid part. Let's also create reference point. Tool, reference point. We have a reference point, and also we need to convert this tool, the solid part, to hollow part by convert create chair from solid option and select this part. Click done. Now we have hollow parts and convert it to solid to shell element, shell parts. Now let's go to property module, and we have our material property. Let's edit and take a look at this material. We will use Johnson-Cook damage property, and we'll use Johnson-Cook damage with different parameters. Damage evolution with displacement at failure options, and also we have density is in the kilogram because we have dimensions is in the meter, and also the density is in the kilogram per meter cube, and also elastic property with Young modulus is in the Pascal. Poisson's ratio, and now we have plastic property with Johnson-Cook hardening with different parameters in the megapascal, in the Pascal, and click OK. Now let's create material section Johnson-Cook solid homogeneous. Click continue. Material, click OK. Let's select the stock and assign the material to our stock. Click OK. Now let's go to, we have the right assembly. Let's go to step, create dynamic analysis step, dynamic explicit analysis, and also we need to change the time period of our operation. This operation take 0.1 second, and also let's add mass scaling options to simplify and run our job faster. Use scaling by factor or use scale by target. 10.5, or you can use 100 in this option. Click OK. OK. And let's go to file output and change and select some property. Damage initiation criteria. Also, we have many options to see our damage. And also let's go to status and select status, some failure and plasticity models. Click OK. Now let's go to interaction and let's create interaction between stock part and drilling tool. Let's go create interaction property 1, mechanical tangential behavior and also normal behavior. In the tangential behavior, we will use penalty options and 0.3 as friction coefficient. Click OK. And now let's go to mesh before and return to the interaction module. Mesh. Let's mesh our parts individually. Mesh our stock with 0.001. 1 millimeter is in the size of our mesh. Okay. Mesh our part. Click yes. Now let's go to type element and select 3D explicit analysis, 3D linear element, and use element deletion to delete the failure to delete the element that have damage and reach the failure criteria. Click OK. And now let's go to drilling tool and select tetrahedral element. OK. Element size 0.2. Apply. OK. Yes. Go to, go to element type. Click done. We have this right rigid element. And now let's go to interaction module and create interaction between two parts, the stock and drilling tool. Surface to surface contact. Continue. The first is the drilling tool surface. Click done. Let's select the brown side of our shell part, shell element, brown, and also select node region. And let's select the node in our stock part. I think we forgot to select this surface. Let's return and select also this bottom surface. Click OK. Brown side, node region, and select this part. That means we select all nodes in our stock. Click OK. And let's change to penalty contact method and click OK. Now we have the interaction. We create the interaction between drilling tool and our stock. Let's go to load and create boundary condition of our assembly. The first is symmetry, anti-symmetry on caster option in the initial step. For our stock, let's select these faces, the side faces. Clicked on and pin it, select pin it option, click OK. Now let's create displacement rotation, click continue, select reference points, clicked on, and we avoid, let's avoid the movement and translation is in X and Y direction, also and the rotation. No, we can't. Let's cancel this option. Let's create in the initial, in the step one, velocity, angular velocity of our tool, select reference points, and apply our boundary condition and our speed and feed rate to our tool. We have the translation of our tool in the z direction, the translation, and also the rotation around the z axis. We have translation in the z direction. The first is the feed speed. Let's use 0.002. The speed is in the meter per second. That means that displacement 2 millimeter in the second in the displacement, or we can change to 1. The displacement is equal to 1 millimeter per second. That 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 unit, this unit of our feed speed. And also let's add the rotation speed of our tool. The rotation speed is equal to, is with unit radian per time, equal to 0.01, for example, 0.02, for example, 0.02 radian per time. And let's click OK. But before we go, we have displacement 1 millimeter per second. That means we have 10 millimeter in the width of our stroke. That means our tool need 10 seconds to create a hole, uh, to create a hole in our part. We have 10 millimeter and our tool with feed rate equal to 1 millimeter per second. That means our tool need 10 seconds to drill our part. This value 10 seconds we need to in our step 1, edit this. That means we need to add 10 seconds in our time period, or we can use 1 second to the period of wall operation and make our drilling operation more faster. Load and edit. That means we add, that means we have more time. That makes our tool drilling faster than 1 millimeter. That means we have 1 millimeter per 10 with unit meter per second. Click OK. Now let's go to our job and create our job. I think all steps are done. Let's create job, drilling, continue, realization, use multiple, Okay, let's first check our model. Let's analyze and see our result. Let's go to result and see the operation of drilling. Let's hide unnecessary edges in our parts. Free edges apply. Okay, and this is our result of our drilling operation using abacus. And now we can see the failure and damage of our aluminum plate under drilling operation. Let's get some data and energy of our operation. This is energy of drilling or of in the wall model, and also the strain energy, and also kinetic energy. Let's plot our animation. Link to viewport. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you.